In this video, we're going to look at finding limits algebraically. So we spent a lot of time looking at graphs and tables, and now we're going to go back and focus on expressions. I just said that. All right, so we're going to use our limit laws, which we previously learned to evaluate this limit. So I'm going to do it a little bit quicker. As you learned the limit laws before, we can break up this into multiple limits with the addition sign. All right, so everywhere there's an addition sign, I can write it as a separate limit. And then I can keep simplifying this further because the limits behave nicely with exponents and constant multiples. So this exponent squared, I can do after the limit. I put this 2 in front. That's a constant multiple. And then 3 is a constant, so I'll just leave that one. Right. So this is the simplified version using our limit laws. We've gotten to the point where our limits are just a single x or just a constant. And now for each of these individual limits, when you take the limit of x, you just get whatever your x value is. So that's going to be 1. Again, the limit of x is 1. Plus 3. All right, so this is how we can evaluate the limit, and then we'll do some steps to simplify it. All right, but we look at what we have right here, and we compare it to our original expression. You can see all that happened was x squared became 1 squared, 2x became 2 times 1, and 3 became 3. And that's the exact same thing as if I had just taken this 1 and put it in for the x's. And that's going to be the thing that we're going to learn in this video, that in a lot of cases, when you're finding a limit algebraically, you just plug the number in. You don't have to do anything complicated. You don't have to do all this stuff here. You can just skip down to this step and get 1 plus 2 plus 3 is 6. All right, so the limit laws are important to know because there are going to be questions that focus on them on the AP test, but in practice, when we're doing it with an expression, generally we don't use them. And that's what this says. All right, polynomials are the nicest functions we're going to work with all year, and we're really going to focus on them in the fall. All right, so if p of x is a polynomial, we want to find its limit. All we have to do is take this a value and plug it into our function. We don't have to do all the limit laws. We don't have to graph it and look at it. If it's a polynomial, which again just means coefficients and powers of x, so like this would be a polynomial. We can add bigger powers of x. All right, that's a polynomial. If it's just coefficients and powers of x, it's a polynomial. Just plug in your value. Rationals are just made up of polynomials, but the division means sometimes it's not going to work out as nice. So if we have a rational, which is just 2 polynomials divided by each other, as long as we're not going to divide by 0, then we can just plug in the number. So we just check that first, make sure we're not going to plug in 0 or divide by 0, and then just plug in numbers. All right, so we're going to find this limit. Generally, it should be parentheses around there to make it a little less confusing. All right, we see it's a polynomial. It's just x's and coefficients. So we just take that 3, plug in for x, and I get 14. So no having to break this up using the limit laws and everything. We just go straight to the answer by plugging in the number. All right, evaluate this limit. All right, if you're evaluating a limit with a rational, the first thing you want to do is look at the bottom. So on the bottom, -2 minus 4, if I were to plug that in, I get -6, which is not 0. And as long as it's not 0, I can do the same thing I just did in the last example. Take this limit, just put in -2 for all my x's, and just simplify. So -2 squared is +4. 2 times -2 is -4. All right, and sometimes students get scared when they get this 0 on the top. 0 on the top of a fraction is perfectly fine. All right, 0 divided by a number is just 0. The problem is when 0 would be on the bottom. So we had the same example and it was flipped. That would be a problem. But since 0 is on the top, we just get 0 as our final answer. All right, what about this one? All right, the first thing you want to check is that the bottom's not 0. 3 minus 3 is 0. So this one we can't do. All right, and we'll see in the future how to do this. If I did try to plug in 0, I get 0 over 0. And although at the beginning, that's a bad thing, getting 0 on the bottom, the fact that you get 0 over 0 is actually kind of a good thing, and we'll see what to do in that situation later. But the important thing from this video, just know that when you're working with a polynomial, absolute best thing that could ever happen. All right, working with a polynomial, just plug in the value for your limit and you're going to get the answer. I've been working with a rational. You just do the same thing, but if the bottom ends up being 0, then you basically say you don't know the answer yet. But if you get anything else other than the bottom being 0, you also know the answer for that rational limit. So polynomials and rationals, the nice case, just plug in your value.